is an alternative to that, and I think you'll find it's actually it's quicker and it's kind of easier than doing quadratic formula. With quadratic formula, there's so many math steps that you can make a mistake on. There's way less here, okay? So, what you do to complete the square. The first thing you do is you add the c term or subtract the c term to the other side. So that term that doesn't have the variable on it, that's got to go. All right, so in this case, I'm going to add it to the other side. So I'm going to do a plus 10. So I've got x squared plus 6x, and then I'm going to write plus blank. Because what I'm going to do here is I'm going to complete the square, meaning I am going to put a number there that creates a perfect square trinomial. An x plus 3, or an x minus 5, x minus 5. Okay, and then on the other side, I'm going to have 0 plus 10, but I'm also going to have a plus blank there, because if I randomly decide to add a number to the left side, I have to do the same number to the other side, or you're changing the integrity of the equation, right? It's not the same equation. So, to get that number, there is a strategy to it, okay? So, I have it written here. It's half of the b value squared. Now, if you don't want to memorize that, basically what I'm trying to do is split 6 up into the same number, because I want it to be a x plus 3, or an x minus 2, x minus 2. I want the number to be the same. The only way to split 6 up to be the same is 3 and 3. So this blank is multiplying those two numbers. Another way to do it is take half of the b value. So I'm going to do this number here, divided by 2, and square that. That's the number that's going in the blank. So in this case, that's 3 squared. So this is a 9, but if I'm going to add 9 here, I've got to add 9 here, right? This is completing the square. The reason it's called completing the square is right now I can factor this, and it's a perfect square trinomial. What multiplies to 9 and adds to 6? 3 and 3. So I can factor this to x plus 3, or x plus 3 squared. Write the left-hand side of the equation as a binomial squared. This is a binomial squared. And simplify the right-hand side of the equation. So I'm going to just add those two numbers together and make this a 19. Okay with that? All right, let's look at the next one. X squared minus 10x plus 4. Right now, to the eye, this is not factorable. If you were to find the discriminant, it would not be a perfect square. There are not any numbers that multiply to 4 and add to negative 10. So I normally would have to use the quadratic formula, which you still could do, right? This is an alternative to that. So in order to complete the square, the first thing that you do is you move the c term to the other side. Right, so I'm going to subtract that number over. In that same step, I want to leave room to complete the square. This number is going to be a perfect square. And then the other side, I've got 0 minus 4, and then I need to leave room for the completed square here too, because whatever I decide to add to the left, I have to add to the right too. I want to split that negative 10 up into the same number twice so that it's a square, right? So it would be negative 5 and negative 5. And then multiplying those two numbers gets me my perfect square, 25. If that doesn't make sense, it's the same process over and over again. It's half the middle number squared. And I'm putting it in parentheses just because when you square a negative, if you don't use parentheses in your calculator, you'll get it wrong, right? So I'm doing negative 5 squared. That's the number that's going in the blank. Half the middle number squared. So this is 25. The significance of the 25 is it creates something that's factorable. What multiplies to positive 25 and adds to negative 10? X minus 5, x minus 5, right? Or x minus 5 squared. It's called completing the square because this is the number that makes this a perfect square trinomial. And then I just do the math on the other side, 25 minus 4. right? So completing the square is taking something that's not factorable and making it factorable, right? Everybody okay with those first two? So we're moving the C term, taking half of the middle number, squaring it, and adding that number to both sides. What that will create is something that's factorable on the left. So how is this an alternative to quadratic formula? So I'm just going to show you how we would get the same thing using, so this is example 1 on your paper. And we just did complete the square and we got this. I want to show you how using quadratic formula would get me the same thing. All right, so if I were to use quadratic formula here, I would get a discriminant of 76. I just showed the work here. B squared minus 4 times A times C, 36 plus 40 gives me 76. So in quadratic formula, it's opposite of B plus or minus the discriminant all over 2 times A, which in this case is 2. Now, if I'm looking to simplify that 76, I believe it goes into 4. So when we're simplifying perfect squares, I'm going to use 19 and 4 for that. So this becomes 2 root 19 all over 2. And then since all of these things are divisible by 2, I can reduce them to this, right? Negative 6 divided by 2 is negative 3. 2 divided by 2 cancels out. Now over here, if I wanted to solve this problem for x, because that's what quadratic formula essentially does, right? It gets you what x equals. Well, what I could do is I could take the square root of both sides, and that's going to get rid of the square here. And that's going to give me an x plus 3 on this side. And anytime you take the square root of a number, you get the 2 answers, right? You get the plus and the minus. And then I would subtract the 3 over. And you can see I end up with the same thing that I do for quadratic formula. So you can use quadratic formula to get negative 3 plus or minus root 19, but you can use complete the square to do the same thing. And that process was pretty simple. I just had to add one number, right? So it is an alternative to quadratic formula. Now that's not why we're going to use it, but it does work. If you decide that it's really easy to do and you hate quadratic formula, it is a good alternative for that. It's not the reason we're going to use it though. We're going to use it to graph, but it does work, right? So complete the square when the middle number is odd. On your toolkit, this is examples 3 and 5. My recommendation for you is if the middle number is odd, quadratic formula is the better way to go. All right, this really only works well if you can divide the middle number by 2 and square it easily. Me dividing 5 by 2 and squaring it is not something I can do in my head really quickly, right? Because I'm going to be working with a lot of decimals. So even though it works here and we're going to do it, it's not exactly the best method, all right? So, to the I, this is not something that's factorable. There's not something that multiplies to negative 3 that adds to negative 5. So I have to use quadratic formula or complete the square. So to complete the square, we take this number here and we move it. So I'm going to move that number to the other side, keeping the first part the same, but I'm going to add a blank. And in that blank is going to be a perfect square. And then on this side, 0 plus 3 is 3, and I'm going to add a blank, because whatever I do to the left, I'll have to do to the right. Now that number that goes in the blank is me splitting up negative 5, but I need to split up negative 5 the same. What would I split negative 5 up into? I want to split negative, like the number negative 5. For example, when I split negative 10, I went negative 5, negative 5. Negative 2.5, negative 2.5, right? Your perfect square is multiplying those two numbers. It's going to be a decimal, okay? But if that doesn't make sense, it's half of the middle number squared. So you can get that number that goes in the blank every time by doing the middle number divided by 2 square that number. Just make sure you use parentheses in your calculator, otherwise it's going to show up as negative. So I'm doing -5 divided by 2 squared. 6.25. That one's not as easy to do in your head. That's why I like even numbers better for this. But my perfect square here is 6.25. And I just have to make sure I add it to both sides of the equation. Now I'm going to do my perfect square trinomial. In order to do this part, you want to bring down this symbol. So since this is a minus, this is going to be a minus. If that was a plus, it would be a plus. This number that goes here is always going to be half of this number. Right? Because when I said, how do we split up the -5? We said -2.5 and -2.5. That's why it's -2.5 squared. So this is half of this. X minus 2.5, X minus 2.5 would get me X times X is X squared minus 2.5X minus 2.5X minus 5X, and then -2.5 times -2.5 is your 6.25. Right, so that's why we're doing X minus 2.5 squared. It's the factored trinomial of that left-hand side. Now the right-hand side, I'm just adding these two numbers together. Definitely not ideal with decimals, but it can be done. It's just a method. We're following the same method every time. So last one, I'm going to take the 2 and I'm going to move it to the other side. I'm going to leave room for a perfect square, and I'm going to leave room for the same perfect square on this side. Splitting up 9 would give me a 4.5 and a 4.5. So really I'm looking for that blank to be 4.5 times 4.5. Or the middle term divided by 2 squared. So I'm doing the middle number divided by 2 squared. So that number that's going to go in that blank that's going to create this perfect square trinomial is 20.25. What's that? Yep. I did half of the middle number and I squared it. So think about, like, if I want to split 9 up perfectly, it's got to be 4.5 and 4.5. So I'm just multiplying those two numbers together. You could do it like this too. That's that 20.25. So that blank number is always half of b squared. Now if I want to factor this, I'm going to create a perfect square trinomial. That's the point of the 20.25, is that it is a perfect square. So to figure out what the number is that goes here, this symbol stays the same. And this number is what I split that 9 up into. I split it up into 4.5 and 4.5. So this number is half of 9. If you were to write out x plus 4.5, x plus 4.5, and multiply it all out, you'd end up right back here. So we're just factoring that trinomial. And then the right-hand side is 22.25, because I'm just adding those two numbers together. And this is a completed square.
What was a negative 2?
Is it? You're right, it is. All right, so what do we get? 8.
18.25.
Thank you. I didn't write the negative. 18.25? We okay with that? I want to just give you a moment to like try some. So in your other workbook on this one, page 2, which is the front of the back cover, the first 4 are like the examples that we just did. So the first 2 match your first 2 and the second 2 match your second 2. So you can use those to try these. And then the second half of class, you can look at the bottom of the page, we'll add a second variable in. That doesn't make it harder, it just makes it more tedious. All right, guys, I'm gonna post the answers here. You let me know if you have questions. So for the first one, I added the 15, and my perfect square was half of 8 squared. So I got 16. So my blank number was 16. You can see that in blue down here. And then when I factored x squared plus 8x plus 16, I got x plus 4 squared. My right-hand side was 31. Anybody have questions on the first one? For the next one, I added 9, and then I've got my blanks here. In that blank is half of the middle number squared. So half of -2 is -1. -1 squared is 1. My perfect square was 1. So my perfect square trinomial was x minus 1, x minus 1, or x minus 1 squared. And then my right-hand side becomes a 10. We okay with those? Definitely the easier of the options is when we get even numbers as your middle number. The next 2 examples we had odd, so you're working with decimals, which isn't as comfortable. So I subtracted 1, that's the -1 here. My perfect square was -4.5 squared. Splitting that -9 in half is -4.5. Squaring it is 20.25. Factoring the left is x, and then I kept the minus, and half of 9 is what goes inside the parentheses, which is 4.5. And then the right-hand side is just combining those 2 things. Adding 5. My blank number is half of 3, which is 1.5. Squaring 1.5 is 2.25. My factored form, I'm keeping the plus, and this number is half of 3, which is 1.5. You can keep that as a fraction if you want, like 3/2 is fine too. Eventually, we'll start to graph these, so the decimal makes it a little easier to see on the graph. And then 5 plus 2.25 gives me 7.25. All right. Second half of the class, we're going to continue to complete the squares. We're just going to do it with 2 variables. That's not harder. It's just more work, okay? So in your toolkit, this is examples 5 through 8. So we're going to end with 5 through 8 in the toolkit, which I think should give us enough time to get your midterms back, hopefully. So multiple variables. We're still going to move that last number, the one that's the constant. So I'm going to subtract the 1. In that same step, though, I'm going to reorder a few things because I'm going to want to complete the square with x and complete the square with y. So in the next step, I'll do x squared, and I'm going to pair that with the 2x because they're like variables. And I'm going to give myself a plus blank, and I'm going to complete the square there. And then I'm going to have a y, my y squared minus 4y. So I'm pairing the y terms together. And then I'm going to have a plus blank there because I'm going to complete the square with that too. So then on the other side, I'll have my -1 from the 0 minus 1. And I'll have a plus blank because I completed the square twice, which means I'll have to add both numbers I added to the left side to the right side as well. From here, it's the same process. You're just doing it twice. So this number is half of the middle number squared. And this number is half of the middle number squared. Same idea here, right? If I want to split that 2 up perfectly, it's 1 and 1. and then squaring that, 1 squared is just 1. If I add that to this side, I've got to do that here too, though, right? So whatever I do to the left, I have to do to the right. Half of -4, if I want to split -4 up, that's -2 and -2. And the square of that, -2 times -2, is 4. And I'll have to do that over here as well. So whatever I add to the left, I'm going to add to the right. And now I've created 2 perfect square trinomials. I'm factoring them each, right? What multiplies to 1 and adds to 2? 1 and 1. Or x plus 1 squared. Notice I'm bringing the plus down, and this number is half of this number. That's always going to be true. Plus, what multiplies to +4 and adds to -4? -2 and -2, or y minus 2 squared. Notice I brought the minus down, and I took half of this number. That's consistent, always. It's the same process. And then the right-hand side, -1 plus +1 plus 4 is 4. Tomorrow, you'll learn that this is the graph of a circle. And you'll learn how to graph the circle on a coordinate grid. Alright, so 2 variables creates the shape that's called a circle. And we'll talk about that more tomorrow, okay? So you're going to try this one. Instead of giving you workbook practice, this one's super similar. So take a moment, try this. Everything's even, so it should work out pretty nicely like this first one did. So you're first working on filling in those blanks. Someone tell me what my first perfect square is? 25. I'll put that on this side. And what's my second perfect square? 16. All right, so we've got that factored. What do we got? We've got 41 minus 32. All right, so this side of my equation is 32. All right, but now I need to factor, right?
X minus 5, and then X minus 4.
Yep. This number right here is half of that. In other words, what multiplies to 25 and adds to -10? -5 and -5. And then -4 and -4. The symbol stays the same, half of the middle one. And so this is the equation of a circle. You'll learn how to graph that tomorrow. The last 2 examples on your toolkit are not any different. You're just going to get decimals. All right, I'm thinking I'll show you 7. I don't think we need to do 8. Is that fair? Not different, just more annoying because you're doing it twice, and they're odd, which is going to create these decimals. All right, so I am going to move the 2. And I'm going to reorder some things, right? So I've got x squared, and I'm going to pair that with 7x. And then I'm going to have some perfect square there, all right? And then I've got y squared, and I'm going to pair that with a 3y, and then I'm gonna have some perfect square there. And then on the other side, I'll have a positive 2, because 0 plus 2, and then 2 perfect squares. All right, to get the number that's going in this blank, I'm doing 7 divided by 2, splitting that 7 into 3.5 and 3.5, and then squaring the 3.5. So 3.5 squared is 12.25. So that's my first blank. And since I'm adding that to the left, I'm going to add it to the right as well. This blank here is half of 3, and then I'm going to square that. So I'm doing 1.5 squared. 2.25 is this perfect square. So I'm adding those two together, plus the 2 from before. So 16.5 ends up being this number on this side. On this side, I'm factoring. It's just a little harder to factor because it's decimals. So for this one, it's just easier to memorize the steps. All right, so I'll bring down the symbol, which is a plus. This number here is always just splitting this up, dividing it by 2. So it's 3.5, and then that will be squared. And then I'll bring down this symbol, which is a plus, and divide that by 2 to split it up perfectly will give me 1.5 squared. And that's complete square. You guys think that's okay? Not too bad? Tomorrow you'll learn how to graph it, which is actually easier than doing the process, okay? It's super, super easy. We are done for today. You have a Canvas assignment that you could probably get done right now while you're working on that. I'm gonna come around with your midterms for the